Hello everyone. This video is made in continuation to the previous technical seminar video. Here we'll be discussing about the results obtained by each method. So let's begin. Here in the Google Inception V3 CNN architecture, the left figure shows the visualization of multiple types of skin cancer that were visualized using TSCN visualization. The system used to obtain the following result was built using partition algorithm technique. This is the image that I'm talking about. Now, in the top right image, a three-way classification accuracy comparison was done between algorithms and dermatologists. The dermatologists are tested on 180 random images from the validation set, 60 per class. The three classes used are first level nodes of a taxonomy. A CNN trained directly on these three classes also achieves inferior performance to one trained with the partition algorithm. The results from these two algorithms in comparison with the dermatologist can be visualized in the top right image as pointed out before. As seen, it can be noted that deep learning algorithm performed much better than a dermatologist in classifying with a higher mark in accuracy. Not only for accuracy, but also when we compare sensitivity and specificity, the deep neural network outperforms the dermatologist. This proves that deep learning makes the lives of doctors easier, and along with that, it makes their diagnosis to be of higher quality. The sensitivity versus specificity graph is shown in the bottom right image. The figure consists of skin disorder that are compared with doctor's diagnosis. Here, dermoscopic images are used. It can be seen that the accuracy is 72.1% with plus or minus 0.9%, and the specificity is 0.95 with sensitivity being 0.96. In the second paper, where translational bioinformatics technique is used, the author's main aim is to gather all the data and use necessary tools that are mentioned in the methodologies to augment them and finally extract information on the patient health condition. However, in the end, there is a requirement of a doctor for concluding what the patient should and shouldn't do. Using this technology helps the doctor streamline the huge set of data that is collected and focus on the important details and not be sidetracked by the ones that are not to be under conclusion. This vast amount of data gives the perspective of general health of a necessary region. Knowing this can be highly advantageous in improving the state of the health condition in underdeveloped countries which lack advanced medical tools. This can be seen in the figure as seen. Here, Fitbit data is being used. Now, moving on to the third paper, where a deeper architecture is used. Here, in order to find the true efficiency and accuracy of deeper, the authors had to compare it with other algorithms. BOW plus LR was used. It was concluded that deeper is far superior as it provided a linear decision boundary, while BO plus LR provided a scattered one. This can be seen in the left image. The figure shows 2D projections of classification on the unseen test set of two methods, bow plus LR and deeper. White points and blue background are negative class, black point and yellow region are positive class. The figure shows deeper groups similar patients and creates a more linear decision boundary, while bow plus LR scatters the patient distribution and has a more complicated decision boundary. The decision boundary is approximated by an exhaustive contouring method where fine lattice points of the background grid are labeled to the predicted label of the nearest data point, and then the boundary is computed by contouring algorithm. When the accuracy of the two models were put to test, deeper performed with a higher score as shown in the figure right. Accuracy is between 79.5 and 81.9% for deeper, with a linearity being of 0.93. Now, moving on to the fourth paper where spectral domain pre-processing was used, the authors used different datasets to train the algorithm in order to check its accuracy on its data analysis for classification. This can be visualized in the top left figure. which consists of different data sets that are being used. When the program was run, it was found that the results obtained had higher precision and sensitivity. The sensitivity here is also termed by recall percentage, which can be seen in the right image that occupies the entire length of the presentation. It was uh, it was accurately able to analyze and classify different activities done by the human. This data can be visualized as mentioned below in the right image. Along with this I percentage values and values of sensitivity and precision, the accuracy obtained by this method was too high. This data can be viewed in the bottom left image. So, as seen, overall, it can be stated that the average accuracy is 95.62%, with sensitivity being 98.15%, and precision with 97.40%. So this slide in brief tells the overall methods being used with its advantages and disadvantages and the final parameters that were obtained in the results step. So after observing this table, it can be concluded that the spectral domain pre-processing method is the most efficient and accurate, with accuracy being 95.62% as mentioned above. So spectral domain pre-processing method is the best method with high sensitivity, precision, and accurate for data analytics and classification. Thank you and have a nice day.